All right, so in last few lectures we have been discussing about information cascade. Particularly we have started discussing on decision based model, and we have seen different cases where we choose a single strategy or multiple strategies and so on and so forth, right. So if you remember last lecture, we have stopped here where we have shown that in the space of A versus C, where A is the payoff when you adopt strategy A and C is the cost when you adopt both A and B strategies at the same time, how would the space look like, right? And we have seen that particularly cases like here where you basically you are sticking to a particular strategy B, which was your earlier strategy, but gradually a new product, a new strategy penetrates the market and you are moving from this region to this part of the regions, and then when you have actually capitalized on the entire market, you have convinced your customers to retain the strategy A, you would essentially increase the cost, right, with better products, better quality, and customers will also be happy because the quality of the strategy, the quality of the product is essentially very good, right. That's why the customers will not switch to any other strategy. Now let's look at a real application, a real case study of a decision based model. Okay, so this case study, and this was basically a movement that happened way back 2011 in Spain. In Spain, Spain witnessed one of the highest unemployment rates across Europe in 2011, and that was around 21% unemployment. And the entire crowd of Spain, they were extremely unhappy. They started protesting against the government, right. Government also started taking many activities. For example, government increased the retirement age of working population. Government gave access to cheap labors, to business owners, but none of these strategies actually worked out properly. Okay, so all these strategies were not acceptable to the citizen of Spain, and they started a movement, and this movement actually started on social network. Okay, and we will show that how strategically people recruited citizens in Spain or again outside Spain, so that mass protest could happen against the government, and gradually how things became normalized, right. So in 2011, right, at that time Twitter was also quite new, right, but they chose Twitter because at that time Twitter was not that crowded, and most of the government personalities, most of the political party leaders, they were part of Twitter, and at that time Twitter was not that noisy, right, in the sense like if you look at Twitter these days, you would see a lot of garbage things, right, fake news, misinformation, and a lot of other crap activities. But that time Twitter was quite new, and then people respected the platform and joined there to consume information. Therefore, the protester chose Twitter as one of the social media platforms, and then this protest happened, and this protest is called as Indignado movement. Okay, this is a Spanish word, and the meaning of this word is I think this is basically outrage. Okay, and this movement is also called as anti-austerity movement, right? And this is quite popular. If you Google it, you would get a lot of information about this Indignado movement. And it started around, officially started on 15th of May 2011. So in this particular research paper, right, basically the author scraped Twitter data related to this movement and tried understanding how recruitment happened and how actually things moved, right? For example, basically the idea was to understand cascade effect, particularly whether a citizen joined this movement due to social pressure or due to his or her own intention, right? And we'll see a series of such series of metrics that we will use to understand this particular movement on social media. Okay, so these are the following questions that we are trying to answer here. When does one generally start to tweet about the protest? Okay, remember here we are looking at online protest. So say for example, if I tweet about this one, I also become a protester, right? If I tweet against the government, right, I basically become a protester, right? So the second question is, does neighbor have any influence to the answer of the above question? For example, whether I am motivated by my neighbors or I join by myself without any social pressure, right? And how much influence a neighbor actually can make on a particular citizen, right? So this was a study. So what they actually did, they collected 70 such hashtags related to the protest, and they collected around 5 lakhs such tweets related to this protest, and around 87,000 users related to this protest. Okay. So what is the condition for relevancy? And any user who tweeted within the specific set of hashtags and has followers and followees who did the same thing, right? Now these would become the population which we would basically try to analyze. So we look at those users who have tweeted, who had tweeted about this one with one of these 70 hashtags, or those who are followers or followees of somebody who had shown protest, right? All right. So we start off by creating a network. Okay. So we look at two types of networks. One is called a full network. In full network, we look at follower-followee. So users, right? They are linked by this follower-followee links, directed links, and this is a full network. The second one is more of a symmetric network. In a symmetric network, we only consider those edges which are bidirectional in nature, meaning we will consider those edges where A follows B and B also follows A, right? So if you have a network like this, for example, right? So this is a full network, and in the symmetric network we will consider this edge and this edge. So this is kind of an undirected network because we are considering symmetric edges, but this is a directed network. Okay, and for each user we define something called the activation time. So the activation time of a user is a time when the user starts tweeting about the protest. The first tweet written by the user, the time of that tweet is the activation time of the user. Okay, and then we define these two quantities. One is k in. K in is the number of neighbors, right? When a particular user becomes active. So when I become active, when I write the first tweet, what is the number of neighbors? Okay, that's k in. And what is ka? Ka is the number of active neighbors when I join the protest, So K in is the total number of neighbors. Out of them, Ka number of neighbors are active when I join. Okay. So we define something called activation threshold. Activation threshold is the fraction of active users when I join the movement. Remember this, when I join the movement, I calculate this one, activation threshold, Ka by K in. Okay. And recruitment refers to the event wherein a user tweets about the ongoing protest. Okay. So if a new user starts tweeting about the protest, it means that that user has been recruited. Okay. Now we will try to understand the relationship between recruitment of a user, meaning the activation time of a user, and the activation threshold. Okay. So now this is the tentative kind of timeline. If you look at here, this is 15th of May when this movement officially started, and this is 2 days before this, 5 days before this, 6 days before the movement, 12 days before the movement, and the right side is 2 days after the movement, 4 days after the movement, and so on and so forth. And if we just plot NA by N, NA is the number of active users and N is the total number of users. If you look at this fraction of active users, you see this kind of plots, okay, and you see certain some sweet spots, right? Some peaks, some slopes, and so on, right? And this peaks, right, or this sudden increase in slope, this indicates different points. For example, this is the point when the first mass demonstration started. This is the point 6 days before this 15th of May when students occupied the university. 10 days before this, first protest attempted in the main city, and so on and so forth. So if you look at it, it is around 0.98, the total, the fraction. So 98% population were active during that time, active protesters during that time. Okay. Okay. Now let's try to understand this activation threshold, Kn, Ka by Kn. So Ka by Kn, if it tends to 0, what does it mean? It means that I have a lot of neighbors who are not active, right? Whereas Ka by Kn, if it tends to 1, it means I have a lot of active users, I have a lot of active neighbors, right? So what we do here, we simply plot the distribution of this activation threshold. Okay, x-axis is the Ka by Kn, and y-axis is the fraction of users with a given K by Kn number, right? And this red line corresponds to the full network, and the green line corresponds to the symmetric network. We consider two networks separately. Okay. So you see that in this curves, there are two peaks. The first peak is here, and the second peak is here. Okay. So the first peak is at 0th time, where this protest essentially started, right? And this peak is basically at the value of activation threshold of 0. So essentially this set of populations are those who joined this movement by themselves without any social pressure. Okay. So for this set of populations, K by Kn is 0, meaning there is no social pressure. Still they joined because they were motivated to join. They are basically those users, those citizens who started the movement. Okay. And another peak you see at this point, where Ka by Kn is around 0.5, meaning when 50% of my neighbors became active, I joined. Now this is because of the social pressure. Okay, majority of my neighbors became active, therefore I joined. Okay. All right. Now let's look at the time also. So we study the same thing, the distribution of activation threshold during this time and during this time separately. Okay. You see here this red line corresponds to the time after this 15th of May and green line before 15th of May. You see that the pattern is more or less same with more or less uniform. This curve is also uniform, this is also uniform, kind of uniform. It means that and also peak around this time, right. So basically says the pattern is more or less same before the activation because the before this protest started and after the protest started, right. So now we look at another quantity which we call burstiness. So burstiness is defined by, so what happens is that sometimes we do not look at, we do not get motivated by only the number of active neighbors. We get motivated when suddenly we see a lot of my neighbors, started protesting, and that too within a very short time. All right, now let's look at another quantity which is called the burstiness. Okay, so in the last slide we have seen that what's the social pressure, what's the fraction of active neighbors for which I join this particular movement. Now let's look at, now this quantity may not be enough, right. What is even important is to look at how rapidly those active neighbors join the movement. Okay, so say if I suddenly wake up and see that most of my neighbors join the movement versus I see gradually my neighbors join the movement and then I join, right, there is a difference, right. In fact, in the first case, the first situation would motivate you more to join the movement, right. So we define the burstiness. Burstiness is the, so burstiness takes into account two consecutive timestamps at time t, at time t plus 1, at time t number of active users, at time t plus 1 number of active users, and then we look at the difference. Okay, and that is normalized by the active neighbors at time t. So these are all active neighbors, okay, not active users. So if you plot this delta Ka by Ka, right, with respect to Ka by K in, right. So what you see is that for those users whose activation threshold is quite low, for them also this burstiness is low. They are actually motivated, protesters. They join the protest without any social pressure. Whereas if you look at the change in burstiness after 0.5, right, you see a steady increase, right. So it essentially means that this is not only about activation threshold but also the burstiness. Okay, suddenly you see a lot of your neighbors join the protest, that motivated you to join the protest as well. Okay, so high activation threshold users are more likely to join the protest. Okay, if you see a sudden increase. Okay, so now let's look at the cascade. So we have already discussed what do you mean by cascade. So here we look at a follower-followee relation, and if a follower tweets or retweet or tweet whatever the same content that one of his or her followees has retweeted, right, and that too within a certain time gap delta t, we will assume that this guy has got motivated by this guy. Okay, say this guy has tweeted something about the protest at at 7 a.m. and this guy retweeted the same thing at 7:30 a.m. and the window that we are considering delta t is 30 minutes. Okay. So in that case, we will assume that this guy has got motivated by this guy, therefore retweeted. So it means that there is a cascade from this node to this node. Okay. So in this way, we can check the cascade, the depth of the cascade, right? So if we check the depth of the cascade, right, and if we basically plot the cumulative distribution of the not the cumulative distribution, basically the distribution of the length or depth whatever of the cascade, and that too in a log scale, we see that it basically follows a power law, right? Now why these three lines? The black line corresponds to this time gap, which is 1 hour, the red one is 2 hours and the green one is 4 hours. Okay. You see that the length actually follows power law, meaning that there are lot of cascades with small length and there are very few cascades with larger length, right? So higher the size of the cascade, lower the number of such cascades. Okay. The last observation is that, so we look at the core periphery structure, okay, and try to understand whether the initiators are core nodes in the core periphery structure. And you know, this figure may not be that indicative, but you know, I took this figure from the paper, but if you look at the findings, it basically indicates that indeed the initiators were the core users of that network, both the full network and the symmetric network. Okay. So that is about that protest. Okay. You can actually, you know, come up with many such interesting studies with such social media protest based on the evidence. Now let's look at the limitations of decision based cascade models, right? So the first limitation is to define all this payoff, right, payoff values, cost values and so on and so forth. Now cascade is a continuous, cascade grows continuously, right? So defining the reward and other parameters, that would be difficult for a certain information diffusion setting, right? And in many cases, it is not about whether you want to decide your strategy. It is also about whether you accidentally get affected by a certain disease or certain protest or certain activities, right? So therefore, this decision based model may not be good enough for cases like COVID-19 spread or say Ebola spread or any disease spreading, right? Therefore, we will discuss in the next lecture something called probabilistic cascade model, where the nodes will not have the choice to choose which strategy to choose, right? It basically it depends on the spread of the disease. It depends on the way people interact. It depends on other social restrictions like wearing mask, lockdown and so on and so forth. So we'll discuss this thing in the next lecture. Thank you.